Okay, here's the last transformation that we are going to look at before we start putting them all together, and that is compressions and stretches. So typically, we talk about the vertical compression and stretch. Here we've got a parent function that is the square root. So, we hit at 0, 0, 1, 1. Let's see what we got here. We've got 4, 2. And so then again, there is our parent function. No manipulation to our x, just the function itself, the square root. Okay. Next, we're going to look at what happens when we take our output values and multiply everything by 3. So it's going to grow 3 times as fast, not at the 0, 0. There is no change when we multiply that output of 0 by 3. When we plug in 1, though, we take that y value of 1, we multiply by 3. When we plug in 4, we take our output value of 2, multiply that by 3, and we get the 0.6. That is a vertical stretch. We can also vertically compress it. We're going to multiply all of our output values by 1/2. And that makes our function grow half as quickly. Again, when I talk about grow, it's that vertical direction. It's not going to go up as high. So now let's see what happens when we put all of these together. Let's take a look at example 7a. Our parent function here is y equal x squared. And so that is graphed right there for you with the dotted line. And sometimes it's nice to do this in stages so you don't forget what each piece tells you. So let's take a look right here. This x minus 3 part. That's going to take our graph and move everything 3 units to the left. We knew that the plus 4 part is going to take our graph and move it up 1, 2, 3, 4. So everything gets moved up 4. Kind of liking this parabola drawing tool. The last thing we are going to do is multiply by 2, which is going to make it grow 2 times as fast. It's going to make it seem skinnier as well because it's growing faster. The negative is going to flip it over. So instead of going over 1 down 1, we go over 1 down 2. And we get our final version right here. So one step at a time, all together, totally up to you. Let's take a look at our square root function. Again, 0, 0, 1, 1, 4, 2, 9, 3. There is our square root. Keep in mind this is written just a little differently than we looked at a minute ago. And if it's a little unsettling to have that 4, we can go ahead and rewrite this way. Again, the minus 1 tells us we are moving to the right 1. So that puts the start of my square root right there. The plus 4 is going to move that up 4 to right here. And then the negative 2 out front is going to flip it over and stretch it out vertically by a factor of 2. If you are unsure as to whether or not you have put things in the right place, you can always pick an x value, plug it into the function, and make sure that the xy coordinate pair that you get actually is lying on your transformed graph.